Hi, everybody. So in this video, what we're going to be doing is we're going to be taking a look at how MATLAB can interact with text files. And more importantly, how to import from text files to be able to store those into variables and then utilize that data. And then secondly, how to write to a text file as well. So for instance, if you want to be able to write it as some sort of universal um, document that any computer can open. Because if we save it as a .m, maybe not everybody has access to MATLAB, but they want to make sure they see the data. So this is a way that we can go ahead and print that data out in a nice way using a text file. So the exercise that I put together was that suppose we have a text file called data1.txt. And what I did was I just stored it right here under the current folder. So what you can always do is if you want to read from a text file, just drag it in, just copy and paste, and you can drag it in right here into that current folder. And that contains several ordered pairs of integer values. And what we'd like to do is we'd like to be able to develop MATLAB code that will read the data, store into each column of data into a variable, and then we're going to do some things with that data. Okay, so basically just some very basic statistical analysis of that data. Just to illustrate what the data does look like, let me show you so that way we can verify. And I'm going to share this really quickly with you. So give me one sec and switch it over. All right, so hopefully you can see what the data looks like. And essentially what this data is just two columns of data. They're ordered pairs. So we have one pair is 1, 2, 3, 4 is another pair, 5, 5 is a third pair, etc. So being able to try to put this in manually, like we did in the previous example where we only had 5 or 6 ordered pairs, would be much more tedious. So if you're good with being able to import the data from a text file, then you don't have to sit there and you can save several moments of your life being able to do this. So that's what my aim is, to be able to illustrate how to do that. So we're going to start off with our good old CLC, and we're going to clear all. All right. Now, first thing we're going to do, we're just going to go ahead and open up the file. All right. So what I'm going to do is I'm going to use this. I'm going to define a variable FID, file ID. And FID is going to be equal to this command fopen. And fopen, we're going to first of all tell it what the file is. So we're going to say data1.txt. And then the second thing it's going to ask for is permission. And that means, do we give it permission to read or permission to write? All right. So in this case, we're only reading it. So what I'm going to do is I'm just going to tell it R. Now I'm going to run and I'm going to illustrate what happens at this point and what the output is and explain that output. So I'm going to execute this. And notice that right now, FID is equal to 4, and that's a good thing. For those of you that care, if MATLAB gives you a positive integer value equal to the FID, that means it was successfully opened. If it gives you a 0 or a negative value, that means it's not opened. Right? Now I'm going to run it again. And notice this time that FID is 5. Each time we execute the program, there's an increment as long as you haven't, as long as you're opening that specific file. And it's assigning it to a specific integer value. All right, that's how MATLAB essentially remembers what the file ID is at this point. All right, now it's not saying 6, it's a location in memory. All right, so that's a good way to make sure that if you're working with this, that the data is actually opening. All right, now how do we get the data? So now it's open. I'm going to assign all the data to a variable A. So let's say A is going to be equal to this command text scan. And we're going to scan data1.txt, since that's the file we want. Next, we have to tell it what we're expecting, all right? And in this case, what we're expecting is we're expecting ordered pairs. So we're expecting an integer value. I'm going to call that %d, and then another integer value. If I only had one column of data, I would just say %d. Because I have 2 columns of data, I do %d, %d. If I had text, I would do %s. If I had floating point or decimals, I would do %f. So whatever the type is, that's what we put in there. The next thing we're going to do is we're going to tell it when to go to anticipate a new set of data or another element of data inside of our array. So I'm going to call this a delimiter. And delimiter is a special command necessary to say, okay, well, how do I know that we're going on to a next line, right? And so to be able to do that, we know that we're going to use \n, right? So basically what that's saying is that every time I encounter a return carrier, I'm just going to go to the next line and anticipate the next set of data, right? Now, we're going to say, I'm going to define X, the X data, to be everything that's in column 1 stored in matrix A. I'm going to define Y to be all of the data in column 2. Okay, so A1 and A2. Now for text files, we have to use the squiggly brackets, all right? If this was a different type of file, as we'll see with CSV files, we could just use the parentheses and get it to work there, all right? Before we do anything else, let me execute this, and I'm going to show you what text scan does and stores it in A. All right, so I'm going to run this. And all it says is that for A, we just have a 1x2 cell array. All right, so, and then let me show you what X looks like and what Y looks like. So we're going to run that. It says it's empty, so that's not good. So let's see. I see what I did wrong. Since we already defined FID to be the file, then we're going to read it from FID. So I apologize. Don't use the name of the file any longer, okay, because we have to assign it to that file ID. All right, so sorry about that. Let me go back. And I'm going to run this again. That makes a lot more sense. So now we have a 1x2 cell array, and there's 29 elements in the first column, 29 elements in the second column. Right? I'm going to unsuppress X and Y and run that. And notice that now Y is equal to the first array. Or sorry, Y is the second array, and X is going to be that first array. So we have these ordered pairs. All right. So now we're actually ready to do some stuff with these arrays. All right. So the most important part, though, is that we use this code to be able to extract the data. All right. So we were asked to do a number of things. So first, we're going to get a scatter plot. So we're going to plot X and Y, and we'll use the bubble to get a scatter plot. We need the mean, median, mode, and a standard deviation. So let's say mean of, it says mean, median, mode of the second column of data. So that's mean of Y, median of Y, mode of Y, and STD of Y for the standard deviation. And in fact, we can just do fprintfs. We can say mean of second set is, and we can say %f /n. We're going to expect the mean of Y. We could probably copy this a few times and just cut and paste. So bear with me while I'm doing this. And I'm just going to say median, mode, standard deviation. And we'll just change these, median, mode, and STD. I do have to get rid of these that I had. All right. So now we can execute. It says it's not looking, it doesn't like something. So it likes the mean, it likes the median, it likes the mode. It doesn't like STD. let's see, standard y equals square root of the variance. So, well, regardless, maybe I'm typing in the wrong function. If I run it, it still does what we intended to do. So it gives us all the good stuff, right? And I will share the scatter plot with you. So let me do a new share real quick. And you can see the scatter plot is very obviously a linear association, right? So I'm probably using the wrong command for standard deviation. It's probably like stnd or something like that, or whatever it might be. But regardless, if we knew what the correct command was, we could very easily execute it. So that's how we could read in from a text file. Now, of course, we want to be able to write to a text file as well. Right? So I'm going to go back. I'm going to share my screen again. I'm going to cut all this out. And this time what we're going to do is we're going to write. So let's just say that we're going to create some sort of file named exponent.txt. And what we're going to do is we're just going to write out the first n perfect squares, cubes, and fourths, given that somebody enters the integer n. So first thing we're going to have to do, we're going to have to get n from the user. So n is equal to input. We're going to say enter an integer. We're not going to check it. We're just going to assume that people know what an integer is. And then we're going to have to write it. So for us to be able to write this, what we're going to have to do is we're going to have to open up a new file. All right? So we're going to use FID. And this time, FID is going to be equal to a new file. We're going to call it expon.txt as directed above. And this time, remember we had R. This time we're going to W. We're going to write to the file. All right? So that's the permission that we're allowing to give. And we need to use the fopen function. So what we have right now is we just have a function, or FID, to be able to open up some sort of file. All right. Now, I'm going to suppress this for now, and when we're done, I'm going to run it and unsuppress that just to show you what the output is for those. All right. So now we're ready to write because now we have FID. So we just basically have to put this into motion at this point. Right. So we're going to print out, we're going to write out what the first n perfect squares are. All right, so I'm just going to run this the first time just to illustrate how to do this. So we're going to say, first of all, outside of a loop, because we're going to do a loop to find those perfect integers or those perfect squares, we're going to do fprintf, our old friend, but we're going to change the first part of that, because usually we just do something like, here I am, or whatever it is, and it just outputs to the screen. Well, now what we're going to do is we're going to use an input FID, and what that's going to do is it's going to write to this expon.txt. Okay, so FID, and what we're going to write is the first %d perfect squares are, and we're going to do a /n, and we're just going to say n, right? And that's going to write that code to the file. Right? Now we're going to do a for loop. So for I equals 1:1:n, so that means for the first n integers, we are going to fprintf. We're going to fprintf to FID, and then we're just going to fprintf %d, the integer squared, and I'm going to put a space there. And we're expecting that integer I squared. So whatever iteration we're on, we're going to square that iteration, and we're going to end it. All right, so what I'm going to do is I'm going to run this, and I do want you to pay close attention to the left-hand column, the current folder. All right, so we're going to run, and it's going to ask us to enter an integer. So let's just do something like 8 to make it simple. Now again, pay attention over here on the current folder. Notice expon.txt is not available yet. When we execute it, expon.txt is there. All right. And I'm going to suppress this, not that it matters. Okay. Now I'm going to open expon.txt just to show you what that looks like. Okay, so I'm going to open that outside MATLAB. I'm going to change my screen. So let's new share this xpone.txt. Here's xpone text. It just shows us the first 8 perfect squares. So we wrote that out to a file. Now we're going to write over that file with 3 more or 2 other executions here. So let me close this out, and we're going to finish off the program. So we're going to get out of here, go back. The good news is the rest of this I can just cut and paste. And I'm going to change a couple things. All right, so I'm going to put a /n here, just so that way we jump to a new line and the first perfect cubes. And we're going to change this to I cubed. And I'm going to change this. I'm going to put a \n there. This is just for formatting. And we're going to put first perfect fourths. And this will be I to the 4th. Right, now, one thing I didn't do, and MATLAB was forgiving, but I should close, FID. Okay, so I always want to make sure I close out what I'm doing. So let's run it again. And again, let's do 8 just because we already know what the output is. All right. Notice we got 0, and that's because we closed the file. I forgot to suppress that. All right. I want to again open up xpone.txt to show you what it looks like. So give me a moment. All right, and there we are. So now we have the first 8 perfect squares, cubes, and fourths in a text file, which is really cool because obviously if we wanted to do something much more complex, we could write it in that universal format of a text file. We like text files a lot, just for universal conversion. All right, so let me close this. We'll go back here. All right, I think that was about all I wanted to show you with this part of it. I can't necessarily think there's anything else. So hopefully that helps you to work with the text files. Now, if you want to work with an Excel file, which is the next batch that or the next video we're going to try to investigate, we're going to be looking at CSV, separated value problems. So we're going to learn how to work with an Excel file, which can also be very helpful because Excel can go through and try to find non-polynomial sorts of associations and do all kinds of statistical analysis that might be a little bit more cumbersome in MATLAB.